Problem 11. A laser is placed at the point 3, 5. The laser beam travels in a straight line, and Larry wants the beam to hit and bounce off the y-axis, then hit and bounce the x-axis, and hit the point 7, 5. What is the total distance that the beam travels? Well, let's first geometrically construct what this question is trying to discuss. Since this is only in the positive axis, I'll only be drawing the positive quadrant. Let's consider this point to be 3, 5, right? If this is 3, 5, then it must bounce off the y-axis, go on the x-axis, then go somewhere all the way to 7, 5. So 7, 5 obviously is the same y value, so I should probably draw it more realistic. So it'll look something like this, right? So given this information, there's a key assumption that you need to realize, which is that once it reflects off something, a light beam always reflects off and goes perpendicular. So that beam of light, the reflected light, will be perpendicular to its original path. So with this understanding, how do you represent the laser with this given quantity? Well, how do you represent the distance traveled? Well, the distance traveled is just this quantity plus this quantity plus this quantity. And there's a very cool trick within competitive math, which is that you can model the distance that travels within a straight line, because we can obviously solve the distance between a straight line. So how do you represent this distance? Well, this distance is the same thing if I reflect it over, because remember what I said earlier, that light reflects off any object perpendicular to its reflection surface. So this must be the same thing as this side. And you can understand this because just from understanding of physics, right? If light beam were to bounce off at this way, it would go 90 degrees this way. So if that's the case, then if it were to go this way, then it must be the same thing as going this way, but with a 90-degree angle between it. So that's how we can do that. And since this side length, which is right here, touches the x-axis, the reflected line must also touch the x-axis, which is why it goes all the way down to the x-axis. So now let's consider this line right here. How do you represent this line? Well, we want to reflect this line onto this larger line that we've already constructed in red, which is this line right here. How do I put this line onto the red line? Well, I can do it from a series of reflections, right? If I was reflected over the x-axis, I would get something like this. And if I was reflected over the y-axis, I would get something that looks like this. And I know it must go on continuing the line because this point right here is a 90-degree angle again. So what I mean by this is if I were to draw this out, notice that this is a 90-degree angle. So that means if I were to put this line and this line together, it would be in a straight line because again, light reflects off any surface at a 90-degree angle. So that means this blue line, when reflected over the y-axis, must continue the line that was reflected previously. So this point right here, what would it be? Well, we know if it's reflected over the x-axis, this would be 7, -5, which reflected over the y-axis would give you -7, -5. The endpoints are what matters because that's the total distance traveled. So the distance traveled will be simply the square root of 3 minus -7, which is 10 squared, plus 5 minus 5, with 5 minus -5, which is another 10 squared, which will be equal to the root of 2 times 10 squared, which is equal to 10 times root 2. So answer choice C would be our final answer.